Okay, we're going to go through the four-link, uh, four-bar assembly again. There are some interesting issues and some things I learned last time I did this project, so we're going to work with those. The base is still a little bit of a challenge as to why they put so much geometry in there. Okay, so all of these drawings, the sides. We have a dimension there, but there's not really an angle or a radius called out on the assembly isometric. It kind of looks like that's a round, but it's kind of hard to tell what they did. So unless we find something different, it'll be close enough. The links are pretty much the same. Number of instances varies of the through holes. Still look at the dog bone design and from a CNC manufacturing standpoint, it's not the most efficient. And I'd rather make it maybe a little bit smaller, take some geometry out of the center and leave it just a straight bar. But discuss some of those issues in the previously. So the post, short assembly, and the long. So the spacer long, 2.38. Let's see, did we get to the end there? And then the spacer short. All right, so let's go back and identify some of those items. Not sure what popped up there. All right, so we'll zoom in a little bit, 3, 4. And that may have been the issue I ran into last time is, no, I don't, still not seeing it. All right, well, let's go ahead and get started. Item 4 is the H-bolt. 11 and 12 are the spacers. So 11, 12. So I might have missed those completely last time. So that would have been interesting. All right, we'll see what we can come up with. All right, so the spacers will be the easiest to start with. So 1 inch diameter, 0.56, 0.44. So, oh, didn't want to do that. Okay, got my video straightened out. Let's go new. And based on the dimension style, we are in inch. Just a quick double check. Let's go ahead and maximize that. Front plane sketch, circle, place it, and circle and place it. Jump into our dimension, and we are 1.13 on the OD and 0.78 on the ID. And then this is going to extrude out 1.25. And then we can save that as well, let's get back into the drive. And we'll create our new folder for assignment 8, and then this is going to be the spacer long. Okay. Now, rather than redrawing this, we're 1 inch and 0.56 and 0.44 on the spacer short. So I can do a save as, and we're going to save as copy and open. Oops, would help if I renamed it. There we go. All right, and then don't really need to keep the original document since I just saved it. We'll double click, and pretty much a good idea to start at the small dimensions and work to the larger dimensions, and we'll save that one. All right, so then we go start to look at the posts. And the long post assembly will kind of be doing the same thing. We can do this as a sub-assembly. We'll go through this process as as individual components, and then I want to compare to using configurations, using sub-assemblies, so that you see the process. I know that the individual components will pretty much always work. And if there is an issue with a sub-assembly or something along those lines, we'll resolve it as we go. All right, so part inch, front plane, sketch. I'm going to do this as a revolve. So anytime there's a revolve, I still kind of think that revolves are underrated. We have a tendency to stack these up, and being able to get this geometry in one shot helps. All right, so if I close that off, it's not going to ask me to close it when I perform the revolve. And so the post is 2.3. The OD is 1.25, and want to make sure to go to the center line, 0.25. And our post diameter is 0.75, so they're going to give us, if that spacer and the bearings. Just quick double check. Yeah, no, 0.75. All right, so the last then is the height of the flange, 0.125. We can go right into the revolve, 360 degrees. Pick the end face, hole wizard. This is going to be a tapped hole. And we're looking for an 832. And it's not going to be up to next, it's going to be blind. And the tap depth is showing at 0.5. Oh, we go 0.5 and then that should update. No, I went the wrong way. So if I did the thread, it should add a little bit. And 160 thousandths, that's probably pretty close to the tip of a spiral point tap. Just making it even, I would probably go a little deeper, but we'll stay with this on the design. As a general rule, if I have plenty of material, making it 0.75, obviously I wouldn't want to go all the way through, but if I have maybe another 100 thousandths, that's just going to save taps. And from a drilling standpoint, it's maybe 10 more seconds. Unless we're making a million of these, it's not going to add up to anything significant. So this is the post. I double check my naming. Close that. The long post. Post holder long. So, well, I maybe made that a little too complicated, but let's stay with the naming. And they're going through the descriptions, so pretty much a reverse on the names. We're going to be able to look for all of the posts, look for all of the spacers, and then its category is holder, and then its descriptor is long and short. So naming is always interesting when you come into a new team or environment. So in every company will have its naming conventions. All right, so same thing, save as, and this one would go to short, and assuming that the save as copy and open, assuming that the length is the only thing that changes, and we can close the original. And let's see, the long post, the spacer, and then they're doing post holder, but I would, since there is a difference there, 125.75, same dimensions. Oh, I guess I should pull that into this into the frame. Same dimensions all the way around, and then the disc, that's going to be our separate parts. So the quick change then is to make this 1 11/16 and rebuild it and save it. So we can double check our naming, post holder short, save, and close. File new, part inch, front plane, sketch. All right, and then from a convenience standpoint, okay, with the linear, if you do want to change that back over to radial or diametral, you have those options under the dimension. I'm just highlighting the dimension, coming over to its properties, and changing it to diameter or linear, or from linear to diameter, and then occasionally I would want to see the radius. Thickness stays to 0.125, and we'll accept it. And I want to go ahead and use the hole wizard because there is the off chance, it probably won't be a counterbore, but there is an off chance that I would want to make that flush and change it to a countersink, or possibly, less likely is to change it to a tap. But if I use the hole wizard, then it comes back to that ease of changing it rather than adding it later. All right, all drill sizes. If we show the decimal values, that is, they wanted to go 0.19. So our choices are 0.189, 0.191. Rounding off both of those will take you to 0.19. All right, and that was our disk top. And don't suspect that there will be a lot of disks. And usually we'll avoid the punctuation in the name. Dashes or underscore kind of goes back to the DOS days of trying not to confuse the system too much. So let's go ahead and back that one up. All right, so the post holder, the three components. All right, so we'll deal with that a little later. All right, since I'm kind of doing these going in reverse, let's go ahead and go link one, and we'll just do these in sequence. So if we go to design intent, I'm going to look at this from the standpoint of what would I want to do eventually. So if I just draw this and I do the save as, there's 10 times a 1-inch spacing, which means that there are 11 total holes. So that becomes one of my numbers, and then 11 on that one as well. And then we go to 13. So that's going to kind of drive some of the decisions. Both of those are odd numbers, so there's kind of something I can do in the sketch. The overall geometry stays the same. And 12 to 13. So once we create this, I'm going to fly that out of the way. New part inch. We'll go back into the front plane. Probably we'll go with the symmetry just in case. Vertical, go to the circle, looking for that inference line. And we can draw those two. We have a radius of 0.75. So here's where I'd want to change my dimension. I can do that math. But if I change that over to a radius and then switch it 0.75, because eventually this is going to be an arc. And the through hole then is 1 inch. Get back into the smart dimension, 1 inch. Let's see, do not see any relations showing me horizontal. So let's go ahead and mirror it first. So select, control select, mirror entities. And then we're going to have an overall of 12. All right, and then my center line probably will mirror that that geometry. Let's go back into as sketch. And then on occasion, this line would switch to tangency depending on where I selected it. So sometimes it's just easier to pick outside and then go back and do the selections on the to add the relation manually. So let's mirror the entities, pick up our dimension. Let's see what we have here. All right, so they're not showing us. We got 1/2 inch thickness, 375 on the through holes. If we were to add an 1/8 inch, that would be 0.625. It doesn't quite line up, and this is what you don't do, is scale the drawing. But if I'm just visually checking for a missing dimension, I could legitimately make the case that that is 5/8, 0.625. So that's what I'm going to go with. And if we find out later, since that is a missing dimension, I am going to recommend that we put an inspection to it. And then that would at least serve as a reminder that might want to go back and take a look. So we can trim this out, but I'm going to end up with 1, 2, 3, 4, 5, 6 regions, possibly. So we go to extrude this. If it finds it, oh, it found all of it. It ignored the construction line. So sometimes it does pick up the construction line or based on what I select. And I want to make sure we're in that area. All right, so the trade-off is the 30 seconds it would have taken me to trim, I spent selecting a couple of other items. And then I'm not going to put the hole pattern in. I want to keep that separate, and I want to keep the fillet separate. We'll keep that sketch a little on the easier side, manageable side. And I am going to do this as a sketch pattern because I want to be able to change this. The feature pattern has a lot of functionality, but I may end up doing more math than I would like. So the 1 inch on this in geometry, this 1 inch is something that I can verify, and I think it changes where it should change on the 13-inch link 2. And we can go back and verify those. But because there's 11 total holes, if I put that on center after I create the pattern, it helps me with the geometry of it. So let's take a look at that. 0.375. I'm going to escape out of that, go ahead and make sure that this doesn't move by select and control select, make that horizontal. And we're going to go right into the linear sketch pattern, 1-inch spacing. We'll dimension that spacing, and there's going to be a total of 11 holes. Hit the tab to look at the preview. All right, I think we're pretty good there. And then, as I mentioned, if I zoom up and go to that direction, then I can make that coincident. So here's what happens when I go to 13, is because two more, I'm pretty sure that when we add two more holes that I'm going to have to shift to that one or shift to that one depending on which way the pattern falls out. But for this one and the link 1, link 2, the next one, this is going to work through the process. Okay, so up to next and hit OK. All right, so the quick check is to select and control select. Look down here on the status bar. It shows me 1 inch. I'm okay with that. And the last of the radiuses are 0.5. So if we go fillet, and then I'm going to rotate over, give it a pause. I can't really see, but let's see if it goes connected to start loop is usually a good one. I can always clear them out and add them again if I need to. And then let's scroll down a little bit, 0.5, and go ahead and select. All right, so this is my link 1. And they had a -1. All right, everything's good at this point, so I'm going to do a save as and name this link 2 and save as copy and open. And we'll close the original. Don't run into memory errors as much anymore, but on occasion, if we get a lot of files open, it's still a little bit of a concern. So let's go ahead and check. I think it's just good practice that if you're not using something that you would close it and not have it sitting in the background. All right, so because I made this on center, still no dimension for the thickness on that, I should be able to go to 13 and hit OK. Double check my naming. We'll do the rebuild. They left that on position, so again, you can check the status. And we go ahead and one more save just in case. And then we're going to do this save as. All right, so when you do the save as copy and open, there's a lot of times where it's a good practice to save the previous and make the change and overwrite anything. All right, so our difference here is we are going up to the 14-inch, and the spacing goes to 0.95, and we go to 13. So a few little changes, but everything else is the same. So 14, and just a real quick check, 1 inch, 0.75. All right, so we can rebuild that. When I go into the cut extrude and edit the sketch, we're looking at going to a total of 13. All right, so I change that number. That one gets out a little ways. Let's go ahead and change the spacing, 0.95. We'll go find the coincidence. So by highlighting the center point and the origin, we can take that coincident out, and if I drag those, that kind of verifies the spacing stays equal. All right, and we'll just double check that we're saving the link. All right, that'll bring us to the frame and the side rails. Looking forward at the configurable part, having gone through the first couple of instances, and if we were making these in let's just say 6 to 20-inch lengths, and that was going to be a product that we made. I could take this information and that's what I'm going to build my configurations off. So we want to pay attention to it at this point. It's not super critical, but I want to start thinking about those processes. All right, so we have 3 of the links and our post and spacers going. So we'll come back with the sides and the base.